Finally, F4 lets you use a number of special features affecting the spectrum analyzer. Average: the higher is the value here, the higher is the number of scanned traces being averaged together. Therefore, the higher this value, the more stable the trace will be, and the slower the spectrum analyzer will appear to be. Spectrum line will just change the way the spectrum trace is displayed, showing just the outline, filling everything below the outline in color, or filling everything below the outline with transparent color. Tone level activates or deactivates a tone, the pitch of which varies depending on the total power level received through the RF input. Detector type allows you to select what type of detector you want to use for taking measurements. Peak detector is typically used for analog signals, while RMS is used for digital signals. Resolution bandwidth lets you select the bandwidth of the resolution filter used to display the spectrum trace on the screen. Lower resolution bandwidth values offer more resolution in frequency. However, the maximum span allowed is modified. The allowable resolution bandwidth values depend on whether we are working in terrestrial or satellite band. Persistence is a very interesting tool that will show in red the part of the signal that is constantly present through time, while in blue you see the varying part of the signal. This tool can be extremely useful, for instance, to detect satellite beacons. Vertical range: this adjusts the vertical scale on the screen from 1 to 10 dBs per division. Dashed bandwidth, when activated, will show dashed lines comprising an identified RF channel. Reference will freeze the current trace outline so that you can use it as a reference. Marker will activate a secondary marker. We will immediately see a new square on the top right corner of the screen, showing the frequency where it is placed, the signal level measured, the frequency difference between the main and secondary markers, and the difference in signal level between both markers. Max hold will activate the max hold trace, showing the maximum signal level reached so far at every frequency in blue. The permanent option keeps holding the maximum value indefinitely, while karting mode only holds the maximum for some time. Max hold is very useful to catch random spurious interferences. Min hold will activate the min hold trace, showing the minimum signal level reached so far at every frequency in green. Permanent and karting modes work in the same way as previously explained. Min hold is very useful to visualize the industrial noise. Marker trace will let you choose over which trace you want to place the secondary marker. The current trace, max hold, min hold, or reference trace.